Welcome back, Physics 30. So we'll look at a type 3 now. So type 1 was an object launched horizontally. Type 2 was an object that was launched at an angle and has a symmetrical path because it lands at the same vertical height that it started off with. Type 3 will be of this type. So it goes to a certain height and then it falls below. So this could be something that's launched off of a cliff and falls. So you can see T up is not equal to T down. T up is not equal to T down. So take a look at this. Now, I used the same example here. I used the same football one just to make the preliminaries a little bit easier. So from earlier, so key things we need from earlier. So let's see, Vx is equal to 16 meters per second to the right. Vy is 12.0 meters per second up. And what else did I have? Oh yeah, I had T up. T up equaled 1.22 seconds. Now I'm not going to talk about, let's just do this, 1.22 seconds. Now I'm not going to worry about total time because guess what? This is going to have a different time of fall, which I'm going to have to look at. So everything is good up to here. So everything is good. So T up is 1.2. I have these things. I don't have to worry about this distance here yet. So I'm kicking it 1 meter from ground level, or if I'm falling down, it's -1 meter. The key thing is analyzing the second half of it and looking at T downwards. Now to analyze T downwards, what I could do is whether it's, if it's following a path like this or if it's dropped. Notice how this looks like the motorcycle question. Launched horizontally or dropped, it's going to have the same fall. So the second half is like as if I had launched something horizontally and it falls through that path. Launch something horizontally and it has the same path. So I'm going to treat this as this is the starting point. Yes, Vi is 0 if I drop something, or if something is kind of initially going horizontally but then falling through this path, it has the same time down. So all I need to figure out is this D right here. And I think I know it. We knew that the rise, or the max height from before, max height from the previous question was, let's see, what was it? Oh yeah, it was 7.35. It was 7.35. So if I kind of look at this scenario in terms of the second half, okay? So I have, let's see, so I have a 7.35 plus a 1.0 here, because it's one, so it's not at the it's not on the ground, it's 1 meter off. So my 7.35 plus my 1 is an 8.35 meter sticks. Okay, so vertically in the second half, I'll call it. So I can use the same thing that I did back when I did that motorcycle question, because it's type 3 is really a combination of type 1 and type 2 together. Now, since we'll be falling downwards through a vertical height, we have to label this as -8.35. My VI, I'm going to analyze this as if I had just simply dropped it. So it's going to be 0 plus 1/2 of -9.8 times delta t squared. So of course this part's going to be 0. So -8.35, a half of -9.8, -4.90. So divided by -4.9, divided by -4.9, and delta t squared will be equal to whatever this is. Notice that a negative divided by a negative is going to give me a positive. Thank goodness, because this is time I'm talking about. So take the square root of both of those sides. and T repre is 1.31 seconds. And of course we know that this is really T down. So if I'm looking for total time is equal to T up plus T down. So my T down is 1.31, and of course my T up from before was the same as it was before, 1.22. So that's going to give me 2.53 seconds overall. Okay, so that's the only difference here, is analyzing that second half of the motion. And then how far did the football travel? Well, the time of flight is a little extended. So horizontally, my time is going to be a little bit different. Okay, so this, we call this Vx is equal to delta dx over t. So my horizontal velocity, that's constant throughout, 16. And the d that I'm traveling is what I'm looking for. How far do I go? And now my time of flight is a little bit different. It's no longer 2.44, it's 2.55. So delta dx is equal to 16 multiplied by 2.53. So that's going to give me 40.5 meters. And I'll just put to the right. Good. So before, what was it before? I think it was 39. So now it's just a little bit further out to the right. All right. Now when you do the assignment, the last question in the assignment is like this, just to give you a quick look at it. Looks something like that. So it's something thrown from the cliff, very similar to the football question. So we can analyze it the same way. You're going to have to figure out Vy and Vx. So yeah, it's its own new question. So you have to figure out Vx, Vy, figure out time up, height of rise by using Vy, and then treat it like this. It's as if it's being horizontally released from this height here. Okay, so you'll figure out the time of fall, and of course the time, you're sort of the height. You're gonna have to include the mountain height or the cliff height of 115 plus the max height that we got from earlier. All right, so you should be able to do that, and that's the last part of this section. We'll see you again.